Okay, thank you for the opportunity. Now I'm going to present Chapter 10 about one sample test hypothesis, study case about LV Florist. First thing first, introduction. What is hypothesis? A hypothesis is a tentative explanation for a phenomenon or observation that can be tested through further investigation or experimentation. It is an educated guess that attempts to explain the relationship between variables or predict a specific outcome based on available evidence or prior knowledge. In statistics, a hypothesis is a statement or claim about the population that is being studied. The hypothesis is typically expressed in terms of one or more parameters that characterize the population, such as its mean, variance, or proportion. Hypotheses in statistics are used to make inferences about the population based on sample data and to test the validity of the statistical models or theories. Types of hypotheses. There is two types. The first one is null hypothesis, and the second one is alternative hypothesis. The null hypothesis is the statement that there is no significant difference or relationship between variables in the population being studied. The alternative hypothesis, on the other hand, is the statement that there is a significant difference or relationship between variables in the population. Hypothesis testing is a common statistical technique used to evaluate the null hypothesis by comparing it to sample data. The test involves calculating a test statistic based on the sample data and using this statistic to calculate a p-value, which represents the probability of obtaining the observed results or more extreme results, assuming the null hypothesis is true. If the p-value is less than a pre-specified level of significance, typically 0.05 or 0.01, then the null hypothesis is rejected in favor of the alternative hypothesis. If the p-value is greater than the level of significance, then the null hypothesis cannot be rejected. There is 5-step producer for testing a hypothesis. Step 1, state null and alternate hypothesis. Step 2, select a level of significance. Step 3, identify the test statistic. Step 4, formulate a decision rule. Step 5, take a sample, arrive at decision. In step 5, do not reject H0 or reject H0 and accept H1. The 5-step producer for testing a hypothesis is a commonly used statistical method to test the validity of a hypothesis. It is used to determine whether the null hypothesis should be accepted or rejected based on the evidence available. Step 1, we have to know first the state null hypothesis is H0 and H1 is the alternative hypothesis. State the null hypothesis or H0 and the alternative hypothesis or H1 in the step you state the null and alternative hypothesis. The null hypothesis or H0 is a default assumption which states that there is no significant difference or relationship between the variables being tested. The alternative hypothesis or H1 is the hypothesis that you want to prove or disprove, which states that there is a significant difference and relationship between the variables. The study case, a florist company wants to determine if there is a significant difference in the number of flowers sold between two of their stores. The null hypothesis is that there is no significant difference in the number of flowers sold between the two stores, while the alternative hypothesis is that there is a significant difference in the number of flowers sold. More specifically, the null hypothesis can be written as H0 divided mu1 is mu2, where mu1 and mu2 represent the population means of the number of flowers sold in store 1 and store 2, respectively. The alternative hypothesis can be written as H1 divided mu1 not equal to mu2, where H1 indicates that there is a significant difference between the population means of the number of flowers sold in store 1 and store 2. Step 2, select a level of significance. The level of significance is designed. The Greek letter alpha is the probability of rejecting the null hypothesis when it is actually true. Common values for alpha are 0.05 or 0.01, which means there is a 5% or 1% chance of making a type 1 error or rejecting the null hypothesis when it is true. In order to determine the level of significance for a hypothesis test, we must consider the consequences of a type 1 error versus a type 2 error. A type 1 error occurs when the null hypothesis is rejected though it is true, while a type 2 error occurs when the null hypothesis is not rejected, even though it is false. The level of significance is set such that the probability of making a type 1 error is acceptable given the consequences of such an error. In the case for LV Florist, if the null hypothesis is that the new fertilizer has not effect on the growth of the flowers, the level of significance would be set at 0.05. This means that if the p-value for the hypothesis test is less than 0.05, the null hypothesis will be rejected and the new fertilizer will be considered to have a significant effect on the growth of the flowers. However, if the p-value is greater than 0.05, the null hypothesis will be accepted and it would be concluded that there is no significant effect of the new fertilizer on the growth of the flowers. Step 3, select the test statistic. In statistical hypothesis testing, a test statistical is a numerical value calculated from sample data that is used to determine whether to accept or reject a null hypothesis. The choice of test statistic depends on the nature of the research question, that the type of data being analyzed, and the assumptions underlying the statistical test. Use the equation for testing a mean when alpha is known. Z equal x bar minus mu divided sigma divided square root of n, where z is the test statistic, x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the sample size. To use this equation, we first need to identify the null hypothesis and alternative hypothesis. Let's say that we want to test whether the average height of sunflowers in a particular field is 60 inches. Our null hypothesis is that the population mean height of sunflowers in the field is equal to 60 inches, while our alternative hypothesis is that the population mean height is different from 60 inches. Next, we need to collect a sample of sunflowers from the field and calculate the sample mean, sample standard deviation, and sample size. Let's say that we collect a sample of 50 sunflowers and find that the sample mean height is 58 inches and the sample standard deviation is 2 inches. We can now plug these values into the equation for the test statistic. Z equal x bar minus mu divided sigma divided square root of n is z equal 58 minus 60 divided 2 divided square root of 50. So z equals minus 2 divided 0.28. So z is minus 7.14. Step 4, formulate the decision rule. A decision rule is a statement of the specific conditions under which the null hypothesis is rejected and the conditions under which it is not rejected. A decision rule can be formulated to help us make a decision about whether to invest in a new fertilizer based on the statistical analysis of the data. Suppose we want to test whether a new fertilizer has not effect on the average height of flowers. We randomly select 50 flowers and divide them into two groups, where one group is treated with the new fertilizer and the other group is not. We measure the height of each flower and calculate the mean height for each group. To test hypothesis that new fertilizer has an effect on the height of the flowers, we can use a statistical test, such as a t-test or z-test, to compare the means of the two groups. The null hypothesis in this case is that the mean height of flowers treated with the new fertilizer is equal to the mean height of flowers not treated with the new fertilizer. The alternative hypothesis is that the mean height of flowers treated with the new fertilizer is greater than the mean height of flowers not treated with the new fertilizer. The study case. So the decision for this hypothesis test can be formulated as follows. First, set the level of significance alpha for the test, typically at 0.05 or 0.01. Second, calculate the test statistic such as the t-value or z-value using the sample mean, standard deviation, and sample sizes. Third, calculate the p-value, which is the probability of obtaining a test statistic as extreme or more extreme than the observed test statistic, assuming the null hypothesis is true. Fourth, compare the p-value to the level of significance alpha. Fifth, if the p-value is less than the level of significance, p less than a, reject the null hypothesis and accept the alternative hypothesis. This means that there is a sufficient evidence to support the claim that the new fertilizer has a positive effect on the height of flowers. And the last one is, if the p-value is greater than or equal to the level of significance, p more than equal to a, fail to reject the null hypothesis. This means that there is insufficient evidence to support the claim that the new fertilizer has a positive effect on the height of the flowers. Using this decision rule, you can make an informed decision about whether to invest in the new fertilizer based on the statistical evidence. If the null hypothesis is rejected, you can conclude that there is sufficient evidence to support the alternative hypothesis and therefore invest in the new fertilizer. However, if the null hypothesis is not rejected, you would not invest in the new fertilizer and would continue to use the existing one. Step 5, make a decision. Based on the p-value and the level of significance, you can make a decision to either reject or fail to reject the null hypothesis. If the null hypothesis is rejected, it means that there is a sufficient evidence to support the alternative hypothesis. If the null hypothesis is not rejected, it means that there is insufficient evidence to support the alternative hypothesis. Suppose LV Florist want to test whether a new fertilizer has any effect on the average height of the flowers. We randomly select 50 flowers and divide them into two groups, where one group is treated with the new fertilizer and the other group is not. The null hypothesis in this case is that the mean height of flowers treated with the new fertilizer is equal to the mean height of flowers not treated with the new fertilizer. The alternative hypothesis is that the mean height of flowers treated with the new fertilizer is greater than the mean height of flowers not treated with the new fertilizer. To test this hypothesis, we measure the height of each flower and calculate the mean height of each group. You then perform a statistical test such as a t-test or z-test to compare the means of the two groups. Study case: suppose you obtain p-value of 0.03 and choose a level of significance of 0.05. This means that there is a 3% chance of obtaining a result as extreme or more extreme than the observed result if the null hypothesis is true. Since the p-value is less than the level of significance, you can reject the null hypothesis and conclude that there is a sufficient evidence to support the alternative hypothesis. In this case, the decision to reject the null hypothesis means that there is a sufficient evidence to suggest that the new fertilizer has a positive effect on the average height of the flowers. This could lead to increased sales and customer satisfaction for LV Florist. On the other hand, if the p-value was greater than the level of significance, say 0.10, then you would fail to reject the null hypothesis. This would mean that there is insufficient evidence to suggest that the new fertilizer has any effect on the average height of the flowers. In this case, you would not invest in the new fertilizer and would continue to use an existing one. In summary, the decision to reject or fail to reject the null hypothesis in the context for LV Florist would be based on the statistical analysis of the data and the comparison of the p-value to the level of significance. If the p-value is less than the level of significance, you would reject the null hypothesis and conclude that there is sufficient evidence to support the alternative hypothesis. If the p-value is greater than the level of significance, you would fail to reject the null hypothesis and conclude that there is insufficient evidence to support the alternative hypothesis. Thank you guys for your attention. That's it for me and have a great day.